Hello, good day. Welcome back. We are on embedded system and we are on learning about ARM Cortex M4 microcontroller programming. We are on day 6. I hope you are getting a lot out of this series from the beginning until day 5, and I'm sure you are revising and you are getting yourself familiarized with all the concepts being taught to you. If not, please go back and revise and get yourself familiar, so it would help you when I move with the further session, so you would be able to follow much closer. Today is day 6, and let's get into what day 6 unfolds for us. Today we're going to learn about GPIO, the introduction to GPIO. What is GPIO? Today's sections you will get to learn about GPIO, what is it, and where you use GPIOs and what is its purpose, etc. And what is a pull-up and a pull-down resistor, where is it widely used, and what is a push-pull and an open drain, what is that about. And then you will learn a lot about GPIO registers, because embedded programming is all about programming with registers, and that includes GPIO registers. So you got to learn and master this. Even if you have to by God all of this and keep everything in memory, then that's well and good. The senior engineers does that. So this is just a good practice for you. So please pay more focused attention. If not, go back to your data sheet and you can also refer back to there. Before jumping into today's session, I would like to give a small introduction about who we are. I represent A2DG. It's a startup company started by Anbukarasu brothers, my brother Alex and myself Arul. We started in 2023. Both of us gathered over 20 years experience in the industry, and we would really like to share our experience and our knowledge to you all there, so you can also build and be a very professional engineer in the future. And our mission is to convey at least to 100,000 students out there and future upcoming professionals through online courses. And the good thing about our service is that you can study at your own pace, at your own time, wherever you are, and that is really good. A little bit about me. I am Arul Prakash Anbukarasu. You can call me as Arul or APA, as popularly as I would like to be. I have 20 plus years of experience in working in various industries in Australia. I came to Australia back in 2003 and did my master's degree in majoring in embedded systems, VLSI, and project management. And since then I've been working under some major industries, mainly concentrating on renewable energy sector that's dealt with solar and wind energy, power systems, lead acid batteries, and network embedded systems that's linked to ATMs, teller cash registers, point of sales, POS, banking automation systems, and smart parking operations. I got a little announcement to make. I have categorized into two different sections: YouTube viewers and internship professionals, as you can read. What is that about? YouTube viewers, you are eligible to get a free e-certificate if you have attended and watched at least 28 classes out of this series. Due to regulations from YouTube, all the videos has to be removed after 2 or 3 days, so you can't go back to revise if you miss on day 1 or day 2, and that's the drawback. So I personally recommend you and advise you to sign up for our internship, where that will acquire you to get a internship certificate. Yes, that is worth a lot in the industry, as you would realize when you get into that interview or after landing into that first job. When the senior engineers assess you, you will sit right on top, because you already got through this 30 days of learning, and this counts a lot. It's not only that, you can get into our learning management system portal and you can get access to everyday session, and that also counts as your attendance for the certificate. Not only that, you also get unlimited access to the course contents and to our course videos. You can stop, you can pause, you can come back and rewatch it again as many number of times as you would like. And if you get stuck anywhere, you can contact our friendly backend support, and they would be able to assist you to move you through the course. So now let's get in. And these are all the materials required for you to get your hands on, so you can get a lot out of this course. So please contact Pantech Solutions. As you can see there, they are a very big manufacturing company, and they would be able to acquire you to get all of this to you, because once you start to practice on your own, that's worth a lot. Instead of just listening to me or reading or watching my videos back, you can get only so much percentage, like about say 15%. Whereas if you have your hardware in your hand, and if you already downloaded the IDE and you can set up a lab environment at home, that indulges you to get more out of this course, because you will be pressing buttons, pushing this input or sending that output, so you will get to learn different aspects, and that stays with you for a long time. And I would say something like 80%, if you have the hardware and if you play around it, then you will learn, because you will be really job ready. So once you are in the job, they don't have to train you much, because you already learned through these 30 days and you would know what to do. If a senior engineer comes and tell you, you would be able to even give them a good response, and believe you me, take my word, they would be really stunned, because I went through that and I experienced as well, so as my brother. So you would hear this from us a lot. So please contact Pantech Solutions to acquire that. Are you excited to get in to see what's unfolding to us today? Let's get started. First, we start with the introduction to GPIO. What is a GPIO? GPIO abbreviates to General Purpose Input and Output. It is customizable. It is also controlled by software. For example, in this picture, it is an 8051 microcontroller. As you can see, it has ports written all over it. Port 0, port 1, port 2, and port 3. Ports are nothing but they are your GPIOs. Whereas I said, the input and output pins, so you can configure these ports as either as an input or an output, and these can be customizable. That's what it means. So each and every pin can be customized, whether to use it as an input or an output, and that can be controlled by the software. The code that you're going to write, that will help you to determine whether that pin is used for an input or an output. So for example, when I say, or when someone points out P3.2, what does that mean? It's on a port 3 and point 2 is the second pin on port 2. So 8051 it is a 40 pin IC, a microcontroller, and as you can see, it has 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 4. So it has 32 ports in GPIO. Likewise, in every microcontroller, the GPIO varies. So you have to stick to your manufacturer and download the data sheet and go through yourself, and so you would be more familiar with GPIO. But for us, with this series, Cortex M4 GPIO, there is 16 GPIOs in this course, so you will get to learn ins and outs of the GPIO. Now let's learn about what these small circuits represent. So when a GPIO output is connected to a current limiting resistor and that connects to the LED, if the LED is connected directly to the ground, that means this circuit is considered as an active high, meaning the output is dragging along with the current limiting resistors, so that would allow plenty of voltage in there, so the LED will be brighter. So if the LED is connected to the ground, then that's active high. Whereas if the LED is connected to the VCC, and we are talking in terms of GPIOs, if the GPIO is connected to the anode of it, then it's called LED active low. Also take this example. If a button, if it is connected, or a switch, if it is connected to the ground, then it is considered as an active low because it's open, no voltage flows through, and the output GPIO input, what it gets, it's a VCC value. Whereas the other way, if the switch can be called as an active high if that is connected to VCC, because when it is connected, the same voltage will go into as the input. So this is the difference between the active low and active high in terms of LED and switch, and this is what we're going to see in the next session about controlling these. Moving on with the GPIO, as I said earlier, 8051 chip got 8 I/O pins. On those 40 pin IC you got 32 pins, but this is a 8051 and the previous one I showed was a different one. In the LPC 2048 it's 32 I/O pins. It's from NXP, from a company called NXP Semiconductors, and this is the one we are learning in this whole course, STM32 Cortex M4, and it has 16 I/O pins, and you will get to learn about what they're all shortly. So what is a pull-up and a pull-down resistor? A pull-up resistor is connected to the power supply, so it can pull the floating pin to logic level high. That's what it is. A resistor that is connected to the VCC, when you can lift and pull to the high level to as close as to logic high, then that's considered as a pull-up resistor. Whereas a pull-down resistor connects the floating pin to the ground, that makes us logic 0. If a resistor that's connected directly to the ground in terms of this circuit, then this is considered as a pull-down resistor because it's trying to get you to the logic level 0. That's the difference. Pull-up connected to VCC, pull-down connected to ground. That's the difference. What is a push-pull configuration? When we talk about push-pull configuration, there is two types of output type configuration. One is push-pull and the other is open drain. So first let's learn about push-pull, then we'll go into open drain. Push-pull is the most common output configuration used. Push-pull out can drive two output levels. What are they? One is pull to ground, that is pull or sink current from the load, pull or sink current from the load, and the other is push to power supply voltage, push or source current to the load. So it has two phases in push-pull. There is a push phase and there is a pull phase. The push-pull output can be implemented using a pair of switches using CMOS technologies. In practical, the implementation in an integrated circuit involves the use of transistors, use of PMOS and NMOS. In a push phase, you give the internal signal, and being VDD is connected to the PMOS will be in active state, and NMOS is connected to the ground. If you know CMOS theory, then you would follow me with this. NMOS will be active low, in other words it will be off, so the VDD voltage will go out to the output pin straight away, whatever the VDD is. So that's the push, so it's pushing down via the drain and it's going out. Whereas in pull phase, the VDD, it is the reverse of push phase. The output drain that's pushing down because the NMOS is active in the off state, so you get 0 voltage, so that's the pull phase. Let's get to understand a bit more about push-pull explanation. Push phase, when the internal signal connected to the gates of the transistor, refer to this picture, is to set allow logic 0. The PMOS transistor, as I explained, is activated and the current flows through it from the VDD to the output pin, and the NMOS transistor is inactive, open, so therefore there is no conductivity on NMOS. When the internal signal is connected to the gates of the transistor, is set to a high logic level 1. If you send 0, then PMOS is active. If you send 1 as the internal input signal, then the NMOS gets activated, so the PMOS, that means it's closed, and the current will start to flow through it from the output pin to the ground, and PMOS will be inactive and open. No conduction happens in PMOS. So that's the logic. In a logic 0, PMOS active, NMOS inactive. Logic 1, PMOS inactive, NMOS active. That's a push-pull. Push-pull, either or. So now let's move on to the second output type configuration. What is it? It's called open drain configuration. In open drain configuration, the logic behind this pin can drive it only to either ground logic 0, or the other possible state is high impedance. The advantages of this configuration is the ability to directly drive a load, the ability to switch external sources that may have higher or lower voltages as close to VDD, and has multiple sensors connected in a multiple configuration. So the one difference in open drain is it doesn't have a PMOS, so it has only NMOS, and if it wants to be connected as close to VDD, then you need an internal or external pull-up resistor to be more operative as it is. So if you take 8051, all the GPIO pins are configured with open drain because it's just how they're manufactured, and that's how they program on that. So open drain outputs are most widely used in communication interfaces where multiple devices share the same bus line. Example, in I2C, one master will be connected to a lot of slaves through two-wire line, the SDI and SCL, which you will learn later stages, and also it also called as a one-wire, etc. When all the output devices are connected to the line or in high impedance state, then the line is driven to a default logic level by a pull-up. As I said earlier, high impedance state is when a device is in a fluctuating mode between 0 and 1, 0 and 1, 0 and 1. So it doesn't know which state, so that refers to a high impedance state. And to pull up to close to VDD, you need a pull-up resistor. So that's what it explained in this line. Now let's move on to GPIO modes. GPIO modes is configured through an enable line. Every enable line, it acts like a peripheral clock, if you like. So first, if you want to activate the port, you need to enable that line first. Then it depends on the input buffer and the output power. The pin gets the value either written to it or read from the pin. So first let's find out how the output mode is configured when enable line is 0. So take this for example. When the enable line is 0, it comes through and hits the inverter. As you know, it inverts the value. So you get 1 here, and the output buffer writes as 1. So this pin, if you put a multimeter in there and find out, then there it will be high, logic 1. And here, because the 1 is coming out, so the input buffer won't be active, because the input buffer is directly connected to the input buffer enable line. So what is enable line coming? 0. So the input buffer has come as 0. So the output buffer having an inverter that inverts 0 to 1. So that's the output mode. That's how it's configured. Whereas the input mode is configured when the enable line is 1. So you have to set enable as 1 to read the input buffer as 1, because 0 doesn't make any sense. So 0 is no value. So output buffer goes to a idle state or non-conducting state, or whatever way you call it. The input buffer gets activated, and that's what you get in the pin read. This is about the output mode and the input mode configuration with enable line 0 and enable line 1. Now showing how this is linked with the help of transistors, how the input buffer is linked directly with the circuit below. So this is how it's going to transfer. So the PMOS is connected to the VCC, and the pin is read on the internal connections that's connected to the gate. So when a VCC is on, when there is enable line 0, it inverts and PMOS gets activated. So whatever you get there, that will go out. So the output is set. If the enable is 1, if the enable line is 1, then PMOS goes to sleep or inactive mode. NMOS is wide awake. So therefore you get a logic 0. So that's how the transistors are linked. Further getting into the logic analysis, writing 1 to the output pin will invert to 0, and because that sends to the output buffer, the PMOS, when it gets 1, then it's activated, then NMOS, if it's 0, it's deactivated, then it gets to the ground. So that's how it's explained with the link of 1 comes through and it inverts. So 0 goes to the NMOS. NMOS is in off state, and whatever the PMOS is high, so the output pin gets the value as 1. How to read 1 from the input pin? In this example, the pin, the internal pin or the enable pin, if you like, is sending a 1, and that sends a 0. So again, that inverts to PMOS. PMOS gets 1, so therefore whatever the value in PMOS, that gets activated and the output is collected as 1. So this is how the pin gets read. And NMOS, it's in off state, which means 0, and it doesn't get any value. So this is how a reading 1 to input pin works. We talked earlier a little bit about the high impedance state. What is that? Is when a pin is not connected to either a ground or to VCC. If it is not connected and if it is in unknown state, then it will fluctuate, and that makes a leakage current goes higher. And when that goes higher, then there is more power consumption. To avoid that, you could either connect to the ground, or you can connect to a pull-up resistor and connect to the VCC. Try to make either 0 state or 1 state. So this is about the leakage current. That's what we talked about earlier. By default, all the GPIOs comes with the input mode. So you need to change, if you want to change as output, you need to tell the program, in the program, you need to tell that's going to configure for output. What is high impedance? So as we were saying earlier, if the input pin is connected as 1, PMOS gets activated, and whatever value it's there, so PMOS will be in operation. NMOS will be off, so NMOS won't be in operation. Whereas if the pin is connected from the ground, it is connected to the ground, so NMOS only works when there is a 0. Means if it gets only 0 value, then it gets active, and what it gets to the ground. So this can only give a 0 or a what is called a floating value. That's what we measure as high impedance, because it's in a fluctuating mode between 0 and trying close to the VCC value. So that's the difference. VCC, when it is connected, then VCC PMOS is active, so therefore you get to the logic 1 or 0 and 1, and here it's connected to the ground, the pin, so you get either 0 or high impedance. And there is no leakage current, therefore less power consumption because it's grounded. Because earlier here we learned about if it is left open, you get into the high impedance state, therefore there is plenty of leakage current and that consumes a lot of power. Whereas in this case it's grounded, so therefore no leakage current, therefore no power consumption at all. What is an open drain? So considering this as an example, the open drain, when you send a 0, it inverts to 1, and the NMOS it gets as 1, and the NMOS the read value, because NMOS is off, and it sends as 0. So that's how it works. Sending 1 via the gate, and NMOS reads as 0, and it goes to the pin, and it doesn't know whether it's a 1 or a 0, so therefore it's in a floating state. So these two are the outputs that you can get from open drain configuration, either ground or either floating. Either ground or floating. So those two are the output configuration types from open drain, ground and floating. For push-pull, you get either 1 or 0, those two states. For open drain, it's ground and floating. How this is looked with an LED with an open drain explanation. So if you want to have the LED to be well lit, open drain with pull-up resistor. If you have a pull-up resistor, then what it does is, even though there is no PMOS, so the NMOS will try to pull up close to the VCC. Therefore, the voltage will be allowed into the LED, so that makes the LED come on, and it will be as bright as your eyes can see. So that's the purpose of the pull-up resistor here. Even though it's an open drain, but if you put a pull-up resistor, that does its job to keep the LED on. Whereas if you want to keep the LED in an off state, then what you have to do is you need to send an input signal or enable signal 0 that inverts 1. That means NMOS is active, so therefore nothing gets in and no voltage goes through, so the LED is in off state. So that's the difference. Here the pull-up works with 1 coming through and sends through the voltage, makes it the LED to glow. Here you're receiving 0, so the NMOS gets activated and it turns off, so nothing comes out of drain and no voltage goes through and the LED goes to off state. So that's the explanation with LED. As I said earlier, the open drain can be explained good with the I2C, inter-integrated circuit. It is one of the communication protocol where I said multiple lines share the same bus lines, HCL. So there are multiple slaves connected on the same line. That's what open drain is good for, and much preferred solution for I2C. With help of pull-up resistors, it will get this value as closest to the VCC. That's pull-up resistors. By default configuration for output mode, it's push-pull is a default configuration, because the output can be either 0 or 1, and that's where you use mostly the push-pull. Now we're going to see push-pull with LED as an example. We just saw open drain. Now how the push-pull will be effective with LED as an example. Now for instance, to turn on the LED, the pin has to be connected with the current limiting resistor. So when you send a logic 1, PMOS gets activated. So if it is a 5 volt, it comes through as a 5 volt. And this current limiting resistor tries to protect the LED not to burn out, because sometimes the LED maybe go a bit above the VDD. So this resistor limits it and allows the required voltage so the LED can come on and stay on. So that's what it's explained. The current limiting resistor 1 you send through and the PMOS gets active, so it's coming through. Say if it is 5 volts, it's 5 volts, and this resistor will limit and only allow what it's required for LED to be on. Whereas to turn off LED using push-pull, it's the reverse. You need to send 0, and once it inverts, when it is 1, then NMOS gets active. There is no power supply, voltage supply coming through, so none will come through this. Only 0 comes through this drain, so therefore the LED will be in the off state. So this is the difference of the two, open drain and push-pull. Okay, I think you must be a bit restless by now, so I'll give you 5 minutes break. So please go and enjoy that break, and I'll see you again in 5 minutes time. Catch you then. Welcome back. I hope you enjoyed that short break, how long it was, and you were able to stretch your arms a bit and try to get that energy back flowing. So, thank you for coming back and staying with me to learn about the rest of the day. Now, let's get into learning about the GPIO programming structure. What is the programming is all about, and how are you going to use the GPIOs in the programming. So programming structure shown here is connected between bus 2 ports. As you would remember in the functional block diagram, every GPIO, I'll show you by using the, sorry, I'll go to the data sheet. This is page 15 on STM32F411. And if you come to the data sheet, these are all the GPIO ports, port A, B, C, D, E, F, H, and this is connected via the AHB1 bus, advanced high performance bus, and that via that bus that's connected to the ARM Cortex M4. So these are all the GPIO and the port pins that we are learning about. So it's connected to the bus, and the bus connected via the port. So that's what here it indicates. Bus connects to IO port, and there are several registers they are used in the GPIO programming. First off in the rank is direction register. You have to say what direction that register is going to represent. So when you consider direction register, there are 4 different types of direction registers. The same register can be used as an input. By default, all the GPIO registers, the output registers, come as input. If you want to change and use it as an output, you need to change the code to 0, 1, that denotes output. Whereas if you want to use that same port as an alternate function, then if you turn the program to 1, 0, then it can be used as an alternate function. And also you can use that same port as an analog function if you write 1, 1 to the code. So I will explain to you in this. First I'll explain what all this, then I will show you the registers. The second one is the output type register. What is the output type register? So far we learned there is 2 types of output type registers, either a push-pull output type or an open drain. Push-pull got both transistors, PMOS and NMOS. Open drain got only NMOS. Push-pull got 2 states, 1 and 0. Open drain got 0 and floating, it doesn't know, so sometimes it can be the high impedance state. So that's that. The third is the speed register. When you want to switch the register between the transition state on a tri-state between zeros and ones, you need to see that fluctuation. So that's where the speed registers are used. And there is input data register. The input data register is the one you use to read any data from that particular pin or from that particular port, particular pin, which you will learn in the next session about using IDR register. And the output data register, ODR, is where you're going to write to that pin, so it can be used as an output pin and you can see the value at the output, and that's that. And there is configuration registers, which you will learn when I show in the next few slides. How does the GPIO subdivision stand in hierarchy? As you can see, GPIO pin can be classified into 4 different usage. If you like to put the word, can be used as an input pin, can be used as an output pin, it can also be used as an alternate function pin, or it can also be used as an analog pin. When you take as an input, you can also connect an interrupt to that input that you will learn. There is a separate session for learning about what is interrupt. You will learn about that, and so this is a hierarchy about GPIOs. And these are all the registers you will be learning just briefly in a while. So there is GPIO port mode register. There is GPIO port output type register. As we learned there is two different types: push-pull and open drain. And there is GPIO port output speed register. There is pull-up, pull-down register, input data register, output data register. You can either set the bit or reset the bit register. And alternate function can be divided into two: low register and a high register. And there is a GPIO register map where you can see through this and see where and which register is mapped, which I will show you shortly. So every GPIO port mode register will have these three values, and these three values are the must. Every register will come with its address offset. It will have its reset values, and it will tell you what mode it is. So these three are in the port mode registers. I'll show you this. Okay, this is the input configuration GPIO pin, the basic IO. It's in the data sheet STM32F411. So let's go into the data sheet. I will see. It's GPIO pin basic IO. GPIO pin basic IO. GPIO pin. STM reference manual. You got GPIO pins. General purpose IO. So again, I would advise you to download this data sheet and go through the GPIOs starting from page 142 downwards to up to I think 160. So this is the diagram where it shows how the input driver is connected and how the output driver is connected. So on any time the Schmidt trigger TTL logic always comes into play. So with this, whatever signal you send through gets through the Schmidt trigger, and then it saves the data in the input data register in the input driver, and the data saves in the output data register in the output driver. So you can write to the output data register and you can read from the input data register. So that's what it says. And as we discussed earlier, it can be used for 4 different types or hierarchy, if you call. One is an analog, one is an alternate function input, and one is you can either use it as an input or you can use it as an output. So that's what it says here. GPIO. So now we're going to get more into the GPIO. So as I said, we can use it as alternate function. So this is a very good example. For pins 8 to 15, that's it for pins 8 to 15, and this is for pin 0 to 7. It can be used for timers, or for example, if you use a alternate function 4, it can be used for I2C1. Also the same pin can be used for I2C1 pin 3 or I2C and timers. So the same pin could be used for I2C or SPI. So that's what alternate function is. Moving along. So that's the input configuration. So the input comes along and it receives Schmidt trigger and it stores the data and got read from the IDR. This is the output configuration. The data comes through, and by default it's set up in this one is set up in push-pull, so it gets the output as PMOS gets active, and the output data got read and saved in output data register, and you can either write from there. And this is the alternate function. After it comes through the Schmidt trigger in the input, it acts as an alternate function, so you can change that to using the same pin either as an I2C pin or SPI pin or CAN bus. In the CAN bus you can use the same pin, so that's what this is. And the analog pin is what you get the value. If you use it in front of Smith trigger, then that's considered as an analog setup. So these are all the input variants that I told you about earlier. Now let's see one by one the GPIO register. As I said, the GPIO port mode register got the address offset 0 cross 0 0. It has two ports, port A and port B. And the reset values for the port mode register is 0C00. So as I said, port mode register is a directory register. In other words, you can set that mode into this following 4 states. If you write 00 on bits mode 1 and mode 1 of 0, if you write 00 here, then that means bit 0 and bit 1 as 0. That means it is configured as an input state. I'll keep it okay like that. If you write 0 1 here, 0 1 here, then that means this port is set to as an output mode. If you write 1 0 here, then it's an alternate function mode. If you write 1 1 here, then that's an analog mode. And this is the GPIO port out type register. As we learned, if it is 0 on bit 15 to 0, if all these bits are 0, then that's in a push-pull state. If all these bits are in 1, then it's considered as an open drain, and its offset value is 0 by 04. This is a speed register. If you set the bits, that is 1 to 0, if you set this to 0 0, then it's a low speed transition. If you set to 0 to 1, then it's a medium speed transition. If you set these two bits 1 0, then that's a fast speed. 1 1 is a high speed. And this is the push-pull register. As we learn 0 0, there is no push-pull. By default it comes as push-pull, so you don't have to do anything. So only if you want to use in open drain configuration, then you have to use this register, pull up or pull down, because as you know, open drain has only ground or floating as 2 states. If you want to get anything closer to the VDD or VCC value, then you need to set, if you are using as a pull-up register, then you need to set these two as 0 1 or 1 0, and 1 1 don't bother if it's reserved. And the next one is GPIO input data register. It's IDR, and its offset value is 0 cross 10. The next one is GPIO output data register, where you can write to this register, and these bits can be read and written by the software, and its offset value is 14. And this is the bit to set either set or reset. And port configuration lock, you don't have to worry. Okay. GPIO, when we learned earlier that it can be set as an alternate function low register or high register. For a low register, the offset value is 0 to 20. Sorry, 0x20. So when you write the bits 31 to 0, and these bits are written by software to configure alternate functions. So they take it as 8 bits. 32 bits is converted to 8 bits, and they come up with this to use alternate function. So for instance, if you want to use AF7, it has to be 0 1 1 1. So how it works is, divide this 32 into 4 of 8 portions or bits. Then you need to make 0, 31, 30, 29, 28, 27, 26, 25, 24, 23, all this to 0, and the rest all 1. That means you are using AF7 on a low register. 20. Whereas when you come and use in high register, if you keep the offset as 24, and again if you set the bits from 8 to 15, okay, 8, where is 8? 0, 8, 1 to 15, okay, and these bits, they're taking it as an alternate function high, 8, 12, 13, 14, 15. This is alternate function low at 0, 1, 2, 3, 4, 5, 6, 7. So let's see alternate function. We talked briefly about the GPIO register mode. So the GPIO moder comes with an offset, and it tells you which mode belongs to where and which pin is connected to where. So we are only using the GPIO moder to tell whether that is going to be an input or an output or alternate or analog. And if you use as an output typer, then you need to set the offset as 0 cross 04. This is like a summary of what we know. This is given on its own, like individual register explanation. But when you come to the register map, it gives the overall. And it's like a table, truth table if you like, something like that, which you get everything in one table. So that's what this is, register map. So we explained this, and this is the push-pull configuration, and we learned about the input function, how it operates with the Smith trigger. In the input configuration, what are all the steps to be configured as an input mode. The output buffer is disabled when the input pin is programmed as input mode. The Smith trigger input is activated. Data present on the IO pin are sampled into the input data register for every clock cycle. Every clock cycle. Read access to the input data register provides the IO state. So you can access to the read to get to read it. This is the output GPIO pin. It's by default it comes as a push-pull because there is a PMOS and an NMOS that we learned earlier. The data gets sent and gets stored in output data register. It's ODR. If you want to learn, I just showed in the reference manual. The reference manual just is said. The pages are from 140 to 160. If you go to the reference manual, then you will learn about what I said. So I advise you to download the reference manual and start to read and get yourself more familiar about what registers are used and where it has to be used. And this is the open drain connection. We also explained about when it used as an open drain, then you need to use an internal or an external pull-up resistor to connect to the VDD. Summarizing why IO programmed as an output, read access to the input data registers gets the IO state, read access to the output data gets the last written value. And the weak pull-up and pull-down resistor can be used by PUPDR register, PUPDR register. And this is about the alternate function that you just saw. Alternate function low, alternate function high. Alternate function low starts from 0 to 7 bits, and alternate function higher starts from 8 to 15 bits. Out of the 16 GPIO that we talked about and learned about, the first 8 bits, when you want to use that as an alternate function, that's considered as a lower, and the last of the 16 bits, the last 8 bits, it's considered as an active high. Alternate function high, sorry. And this is analog GPIO pin, which I talked to you a bit earlier about. So the input gets in and it got read before it hits the Smith trigger. The output type, there are 2 types, as you know, push-pull and open drain. If it is 0, it is push-pull. If it is 1, then it is an open drain. And its offset value is 0x04. And the output speed register, the 4 different speeds, and its address offset is 0x08. And the pull up pull down register I showed you early, by default it comes as a pull up pull down one on a push pull configuration being an output type. Only this register is used if a open drain output type configuration. So if you want to use it as a pull up, it's 0 1. If you want to use the open drain output type configuration as a pull down, then you need to program as 1 0 here, and its offset value is 0x0c. Input data register, its offset value is 0 cross 1 0, where you get to read from that IO port. And the output data register, the offset value is 0x14. You get to write to that pin so your data can be seen. So the alternate functions, the first 7 bits are considered as the low, and its offset is 0x20, and the bits 8 to 15 they're considered as the high state alternate function 0x24. And this is the alternate function mapping that if you go to the data sheet, I will show you where the alternate function is. So this is the data sheet, and going to page 47. I humbly ask you to download STM32F411 datasheet and STM32F411 reference manual, either from STM32 or I can post it in our Facebook group where you can download, and you need to read, because this is very important, because as you can see, the port A, the pin 0 can be used as a timer, and it can also be used as an UR2. For example, pin 7, it can be used as a timer one, it can also be used as a SPI. So likewise, every pin has its alternate functionality. So please refer to this chart, this table, and you will familiarize about the alternate function. If you take PB3, it can be used as a timer too, and it also can be used as a SPI, and it can be also used as an I2C. So likewise, every pin has its multiple functions that you can use. So that's what it denotes. And that's the table 9 alternate function. It's exactly on page 47. If you go to the data sheet, page 47, you'll get to read this. And please do so and get yourself familiarized reading it. Okay, now when we want to write a program to enable to use a port, first of all, you have to enable the RCC registers. RCC stands for register clock control, and you need to enable the bus so that it can communicate to the microcontroller. So that is the only way you can tell which port you're going to use. So you need to enable that port. If you use port A, you need to enable port A. If you use port C, you need to enable port C. So this is the must register you need to consider first to enable, and its offset is 0x30. It's on page 1 and 4. If you go to reference manual, I'll show you the reference manual where exactly this is. One sec. I am in the reference manual, going to page 114. There it is, RCCAHB1 peripheral clock enable register. So this is what you're going to use. If you're going to use GPIO A, you need to set this as 1 so it can be enabled. If you want to use B, this has to be set as 1, or C, this has to be, bit 2 has to be set as 1. If you use port D, bit 3 has to be set as 1. So as a programmer, it's your responsibility to see which pin you can most efficiently use in your program, and accordingly you choose that pin and then say that pin to set as enable. So thank you for listening to me so far. what we learned today, we learned about all the GPIO, its introduction, how and where. You learned about its active low and active high, and the comparatively with LED and switch. And also you learned about pull up and pull down resistor, where it is used and what is its usage and what is its purpose. And also two types of output type configuration, the push pull and the open drain, where the output data can be read in two different forms. The push pull, it gets two states, 1 and 0. Open drain, it's 0 or high state, floating state. And also you got to learn all the GPIO registers, the enable registers, the input data register, output data register, the speed register, etc, etc. So you will be using a lot about this in the next session. And yeah, thank you for listening, and please go through the reference manual and the data sheet and get yourself more familiar about what each and every register does. As I said earlier, it's not only skill set, you also in parallel have to develop your mind as well. So sharpen your dollar yeah, sharpen your saw. It means you need to upgrade yourself to get more out of you, or more out of output that you are referring. So list on 10 activities that you want to upgrade yourself. We are talking in terms of embedded system. Start with embedded system and see what 10 areas that you want to improve. Say you want to learn different microcontrollers, then set that, and how you're going to learn to get that. Or if you want to learn PCB design, how are you going to do that? So the more you invest on you, the more output you get, the more money you can make, and more useful in the company. Or if you want to start your own company, the more you know, the more you can be expert at. And the second one I want to point out to you is, as most of you are all beginners, you're trying to get into the industry, into the market. LinkedIn is the market to develop your professional network. Your network is your net worth. The number of network that you have, the number of people you approach and you talk to them, the more you gain from them and the more you will learn, and you'll quickly progress and shape your future. And LinkedIn is one very good site where you can get to meet all senior engineers, design engineers, product development engineers, product managers. You just humbly send a friendly invitation request to join with their network and say you are a beginner, you want to learn about the industry and want to know more about what's happening, the current trends. I'm sure 9 out of 10 will come back to you and accept you straight away, and they are keen to pass the baton to the young generation. So you are the next future uphold. So we would love to express our knowledge and our experience to you. So you pass on your baton to the other generation. So that's what it is. So please concentrate to sharpen your activities and also start to create that network so you can do in parallel. And don't forget to be part of the involvement, as you already knew about it. First write the top 10 goals that get you a point, and write down 10 ideas to try to achieve those goals, and you get another point. And please dedicate at least 30 minutes a day, or go for a long walk, say 7,000 to 10,000 steps, and that gives you 2 points. You get more refreshed, and that gets your brain really thinking when you go out and watch different things. As a design engineer, few things spark out. So when you go out and see different thing, and immediately you see how that's operating. So instead of getting glued inside, when you go out, you also get to breathe fresh air, and that's refreshing for you. And also please spend 15 minutes to meditate and pray, and that gets another 2 points. And 10 minutes to visualize that you actually accomplish those goals, and you get a point for that. And then spend at least 10 minutes to plan for your rest of your day, or for the week, or what's ahead of you in the next week. So, and also spend at least 2 hours. As a beginner, you should dedicate at least 2 hours to learn slowly. Don't rush through, because Most of these are new to you, or if you're coming back to electronics design, this could be new to you and it can be daunting, but don't worry, I'm here to help you all the time. So please take your time and learn, and that will get you to 2 points. I request you to post all your achievements in the Facebook groups so that the others get look at your approach, and they may be able to be really get motivated, and we just help each other out. So that's how it works in the industry as well. And the end target goal is you have to aim to get 10 out of 10. So please be honest and try to practice all of this. This is for your own good and own benefit, and post your achievements so the others can view and learn from you. And there is combo internship coming your way, so please stay tuned. I don't want to push a lot of information with you straight away, so that's why I started this as a beginner, so slowly I can ease you to the deep end of Cortex M4 series. So the next one up is the intermediate and then advanced, so please buy 3 to get the full benefit of M4. And also further along, there is a bundle combo coming up. You'll get all of these courses listed there, and you will be the first person to get the invite to enroll and register to all of these courses. It's on its way, and please stay tuned with A2DG and you'll hear from us. And I take this time to thank you so much to each and every one of you who've been watching this video and learning from me. Thank you so much for your patience, and go and have that lovely break from the screen. And I wish you to have a lovely, fruitful, productive day. It's Arul Anbukarasu signing off on behalf of A2DG. Huru for now. I'll see you in the next session. Until then, take care. Bye for now.